Chrysler introduced the A500 518 transmission into their truck line starting in the 1988 model year. The A500 is a 904 with an overdrive assembly located in the extension housing. The A518 is the 727 version. Hello, my name is Mary. The A500 and the A518 may appear to be very similar, but there are differences. For example, the A500 has a converter clutch, whereas the A518 did not have a converter clutch until 1992. The number of overdrive direct clutches and overdrive clutches varies from model and engine size. The transmission designators also changed. The A500 with a 904 style case is now known as the 40RH. The A500 with a 999 style case is known as the 42RH. The A518 is called a 46RH. Wayne is in the shop right now, and he will take us through the teardown of an A500 transmission and show the similarity and differences to the 904 transmission.
Welcome to ATSG's Technical Center. I'm Wayne Colonna, and today we're going to go over the A500 and the A518 transmission. I have here in front of me the A500 transmission. The barrel of the case is same as a TorqueFlite 6 or a 904 transmission, with the exception of having an overdrive section engineered into the extension housing. Now over here I have the 518 transmission, and the barrel of this case is similar to a TorqueFlite 8 or 727 transmission, and it also has an overdrive section engineered into the extension housing. Now if you notice, over here we have a case connector. Inside this case connector on the 518, there are only 2 pins in this connector. The 2 pins go to one solenoid mounted on the valve body. That solenoid is for the 3/4 shift, so it's the 3/4 shift solenoid. Now this case connector, as I said, had 2 pins in it, and the 500 and 518 transmissions came out in 1988. Now, in 1992, the 518 has 3 pins in it because that is when they added a converter clutch solenoid. So a 518 will have a case connector with either 2 pins in it or 3 pins in it, depending on what year it is. So the 88, 89, 90, and 91 518s will not have a converter clutch solenoid. Now over here on the 500, visibly you can see that the case connector is larger because it does contain 3 pins. These 3 pins go to 2 solenoids on the valve body. One is for the 3/4 shift solenoid and one is for the lockup solenoid. And this started in 1988, so all 500s will have 3 pins located in the connector. Now by now you should be familiar with the 904 TorqueFlite 6 transmission and the 727 TorqueFlite 8 transmission, so we're not going to spend a considerable amount of time on the internal parts here in the barrel of the case. We will talk about some changes that were made and point out some things that you should know, but the majority of this video is going to be dealing with the overdrive section of this transmission. Okay, we're now ready to start disassembling the A500 transmission. The majority of the bolts have been removed as a time-saving factor for this video. Now the first recommended procedure in disassembly is to remove the neutral safety switch from the case so as to prevent any damage from the pins located inside this switch. Also, make sure that you remove any external linkage from the manual arm shaft so we can get the valve body out later on. And the next step would be to remove the overdrive section from the case. With the 7 extension housing bolts removed, the overdrive section can be pulled from the back of the case. Once the overdrive section has been removed, you now have access to the bearing, to the overdrive piston shim, and we can remove the overdrive piston from the back of the case. Notice that there is not a governor here, like a TorqueFlite 6 or a TorqueFlite 8. We now have an overdrive piston retainer in the back of the case. And the governor is located in the overdrive section in the extension housing. And here are your governor tubes, both feed and return. Now that the overdrive section has been removed, we can move the overdrive section to one side of the bench and start taking apart the barrel of the case. With the overdrive section removed, we now can start disassembling the barrel of the case. The first step would be to remove the pan. With the pan removed, we can now take the filter off. With the filter removed, we now have access to the valve body. You can see our two solenoids here and how the wire comes across to the case connector. Now, when it comes time to removing the valve body, we need to be very careful because the case connector that we saw previously is part of the solenoid assembly which is mounted to the valve body. And sometimes corrosion gets around the plastic case connector, and when we remove the valve body, we can snap the connector. So you may have to take a soft mallet and gently tap on the connector as you lift the valve body out of the case. Here you can see the connector, and this will snap if you're not careful. With the valve body removed, we now can take the accumulator spring and piston out of the case. We can loosen the band and remove the strut. Now we are ready to begin removal of the internal components. We have installed a slide hammer into the pump for removal. Once the pump is out, we can then remove the pump gasket, the forward and direct drum, the band, and now we have a washer. And next we have a snap ring that retains the planetary assembly to the intermediate shaft. This also has to be removed. With the snap ring out, we can then remove the planetary assembly. The sun gear and shell. We can remove the intermediate shaft out of the case. The rear planetary assembly, the rear internal ring gear, and rear drum. With the snap ring removed, we can then remove the washer, which is keyed to the drum, and we can then remove the rear drum assembly, and the rear low reverse band. And now we have all the internal components removed from the barrel of the case. With the internal components removed, we are now ready to remove the intermediate servo assembly, the low reverse servo assembly, the one-way clutch in the back of the case, and the overdrive piston retainer. With the internal components disassembled and displayed on the bench, you can see that it's very similar to the Torque Flight 6 or 904 transmission. The pump and drums are the same, the planetaries are the same, the washers are the same, but there are some differences that you will see. There is one difference. Here we have a one-way clutch in a caged housing, which can be removed independently from the transmission. On Torque Flight 6s and on Torque Flight 8s, you know that you have individual spring and rollers. This particular one-way clutch is found in the 500 transmission, and it is exactly the same as one in a GM 200 transmission and can be interchanged. This also can be used in a 500 transmission that has individual spring and rollers, but the outer race would have to be unbolted from the case so that you can remove the internal cage that holds the spring and rollers from the case, and then you can use this whole assembly as an interchange. Other changes that were made was to the rear drum that the low reverse band rides on, which we were going to show you a little later on, and there are things about the overdrive piston retainer that you're going to need to know that we're going to show you a little later on. Now, this 500 transmission is also found behind a Mitsubishi engine, and there will be differences there. When it comes to the pump, we're familiar with the two fingers that are on the inside of the pump gear. When you have one that's behind a Mitsubishi engine, you will have flats similar to like the 404, 413. Another item that you'll need to know is on Torque Flight 8s, we have a typical planetary system, but in 518s that are behind diesel engines, the planetaries are going to be straight cut. Another item that has changed on 500s has been the direct drum and the intermediate band. You will find on some 500 model transmissions that the drum was made larger and the band was made larger and wider for better durability. So now we're going to take a look at things that changed here with the rear drum and things that you'll need to know about the overdrive piston retainer. During the disassembly of the internal components, we had to remove this snap ring and washer in order to remove the low drum that the low reverse band rides on from the overdrive piston retainer. The overdrive piston retainer is bolted to the back of the case, and the bolts were removed and the overdrive piston retainer was pulled from the case. Now, a change has been made to this drum here. This drum, as you saw, had both the washer and snap ring. And as you can see on the inside diameter that we have a recess in the drum. A change was made where the washer and snap ring was eliminated and the drum has a smooth face and no recess. If you have a drum which has the recess, a washer and snap ring is required during assembly. If you obtain a drum that does not have the recess but has a smooth face, you do not need either the washer or the snap ring. With the overdrive piston retainer removed from the case, there is one item that definitely needs to be checked during overhaul, and that is this orifice screen that's staked in place in back of the overdrive piston retainer. If this orifice screen blows out of the retainer, you will have premature failure of the overdrive clutches. If you are missing this orifice, you can replace it with part number 4412583. When installing the new orifice, be sure that you stake it into place properly.
In this next segment, Wayne will take us through the teardown and reassembly of the overdrive section of the transmission. During this segment, tips on how to identify the overdrive direct clutch drum for the proper number of frictions and steels will also be shown.
As you can see, there were not many differences to the internal components that we saw in the A500 in relationship to the 904. And the same is true with the 518 in relationship to the 727. So the whole overhaul procedure would be the same, inspecting the planetaries for excessive wear in the pinion gears, looking at your bushings and changing your rubbers and your frictions and your steel plates and so forth. So now we are ready to disassemble the overdrive section on this 500. The first thing that we would need to do is remove the round retaining snap ring. All this does is retain the overdrive clutch plates into the housing for assembly purposes. The next step would be to remove the overdrive clutches. Once we have the overdrive clutch pack removed, we now have access to the two snap rings at the bottom of the pack. The first snap ring that needs to come out is the wavy snap ring used as a cushion, and the second snap ring that needs to come out is the flat snap ring. Before the overdrive assembly can be removed from the extension housing, we will have to remove this plate to gain access to a retaining snap ring. Once the plate is removed, we now have access to the retaining snap ring. So we'll take our snap ring pliers and we'll spread the retaining snap ring. And once the snap ring has been expanded, we can then push up from the bottom to remove the overdrive section from the housing. Okay, now that this unit has been removed from the housing, we are now prepared to start disassembling this overdrive section. Now this has an 800-pound spring in it, so care needs to be taken when removing the retaining snap ring that holds this sliding hub in place, because this 800-pound spring can hurt someone if they're not careful. So we're going to place this unit in a press to compress the spring, remove the retaining ring, and then we can start pulling the overdrive direct clutches and sliding hub and the 800-pound spring out of the direct clutch drum. We now have the overdrive assembly installed into the press, and we are prepared to compress the 800-pound spring and remove the retaining snap ring that holds it into place. Before you release the tension from the 800-pound spring, you will also have to remove the snap ring that holds the direct clutches, the overdrive direct clutches, into the drum. And we are now ready to release the 800-pound spring. Sounds like Halloween. Now that we have the 800-pound released, we could remove the sliding hub and the overdrive direct clutches, the 800-pound spring. We can remove the sun gear and bearing. We can remove the planetary. And we can reach down and remove the inner race and one-way clutch. And now we can remove the direct clutch drum, the overdrive direct clutch drum, from the output shaft. But before you do that, you should put marks on your direct clutch drum to the analyst gear so that during reassembly you can index the parts to prevent any possibility of a vibration concern after assembly. So we will index our part on a direct clutch drum and on the analyst gear. And now we can remove the snap ring on the inside of the direct clutch drum. Once this inside snap ring has been removed, we can then slide the overdrive direct clutch drum back so we can gain access to the snap ring that's behind the drum. And with this snap ring removed, we can now remove the direct clutch drum from the assembly. Now, before we can remove the output shaft from the analyst gear, we have to place marks on the output shaft and the analyst gear for the same reasons as to be able to index the output shaft to the analyst gear to prevent any possibility of vibration. So we will make our marks. And now we can remove the snap ring. Now that the snap ring has been removed, we can now lift the output shaft up off of the analyst gear. Okay, now we're ready to get into the overdrive section and many changes that have taken place, interchangeability, things that you need to be aware of. There has been a lot of misassembly that has caused a no overdrive condition or a bind up on a 3/4 shift, all due to not understanding some of the part changes that has taken place. But first I'd like to address the governor. The governor, as you can see here, is similar to the ones that you would see in a Torque Flight 6 or Torque Flight 8. No secrets here, very familiar. You would have to remove this snap ring from the back and obviously remove the E-clip and pull the stem wire out of the governor so that you can remove the assembly from the output shaft. Now this is a check that you'll want to make because the primary weight pounds up against the output shaft, and this causes the primary weight to mushroom, and this could give us a no upshift condition. So this will have to be inspected. Also, you'll have to inspect the bushings on the inside here for any wear or damage, just like you would with any other type transmission. But now we're going to get into how to identify the different overdrive direct clutch drum, because there are 3 different drums, and if you're not aware of these 3 different drums, you could have the wrong amount of frictions installed into this drum, and now we have an assembly problem that can give us a no 3/4 shift, a bind up on a 3/4 shift, or a no reverse. So let's take a look at how we can tell the 3 different drums and how many frictions belong in these drums. When we were removing the 800-pound spring, before we released the tension from the spring, we had to remove a snap ring from the top of the direct clutch drum, as we did here on this pack. Now this snap ring fit in this groove right here at the top of the drum. Now it's the distance that's between this snap ring groove and the top of the drum that determines how many frictions are supposed to be in this drum. Here we have one style drum. Here you can see that the snap ring groove is a little lower, and here you can see that the snap ring groove is even lower. So a measurement is going to have to be taken in order to determine how many frictions and steel plates belong in each drum. So we would take a dial caliber and we would measure from the top of the snap ring groove to the top of the drum, and when we have approximately 100 thousandths, this drum will take 8 line plates and 7 steel plates. This drum will be approximately 350 thousandths, will take 6 line plates and 5 steel plates, and this drum is approximately 485 thousandths and will take 5 line plates and 4 steel plates in this drum. A mismatch here again could give you either a no reverse or a bind up on a 3/4 shift. Another problem that has come up in the overdrive section is oftentimes when you disassemble it, you will find that this planetary section has torn apart. And the reason for this is that this sun gear and shaft with the thrust plate sits down on this 800-pound spring, and obviously this 800-pound spring is compressed, and this planetary sits on top of this sun gear with a Torrington bearing in between the thrust plate and the planetary. And what happens is there is so much pressure squeezing on the thrust plate and the planetary that lube oil has a very difficult time getting in between to lubricate the Torrington bearing. And this is the style planetary that can give us this problem, because as you can see on the inside opening of the planetary, or the mouth, we have a 90-degree angle cut. With this bearing sitting in here, the oil has a real difficult time getting between here and into the bearing to keep it lubricated. So if you have this style planetary and it is not damaged, you would have to grind a 45-degree angle all around the opening here, about 50 thousandths wide. Now, the thrust plate and bearing has been updated, where now the thrust plate have scallop marks in them to allow lube oil to get in behind the bearing. And the bearing has also been updated. It's larger, as you can see from the original. And this will retrofit back to all previous models, and always make sure that you have that angle cut into the mouth of your planetary assembly. The part number for this thrust plate and bearing is 4740774. If your sun gear shaft was damaged due to the planetaries having a lack of lube, and you purchase a new sun gear shaft, pay close attention to the groove here for the retaining snap ring that would hold that 800-pound spring. There has been some of these coming through where they're not machined all the way down and will not retain the snap ring properly. Be sure that the groove is cut the fullest depth of the splines. If you see half the splines cut, then this new sun gear shaft cannot be used during the reassembly. Also, the one-way clutch that's in the overdrive section will need to be inspected for wear as well. The only purpose of this one-way clutch is to prevent a flare during a 3/4 shift as the overdrive direct clutches are being released and the overdrive clutches are being applied. This will momentarily hold during that application. If this fails, you will have a flare on a 3/4 shift. Another area that needs to be inspected is the governor tubes in the extension housing. You want to make sure that these governor tubes are not damaged. One is your feed to the governor, and one is the return from the governor to the valve body to shift the transmission. Also, make sure that the bore in which the governor rides in is not grooved out from the rings or damaged in any way. This assembly can be removed from the extension housing if damage has occurred and part replacement is available. We are now ready to begin to reassemble the overdrive section. So the first step would be to line up your marks that you made on the analyst gear to the output shaft, and you would assemble the analyst gear to the output shaft, and you would put in your thick snap ring. Once the snap ring is in, we can then install the overdrive direct clutch drum by finding our mark so that we can index the drum to the analyst gear. Once the drum is on, we take the one round snap ring and put it into the drum. And now we're able to install the inside round snap ring into the drum. We are now ready to install the one-way clutch and the planetary and the overdrive direct clutch frictions. The best way to install this one-way clutch is to have the one-way clutch onto the inner race and securing the bearing to the inner race with trans gel. And you can place this assembly into the housing, rotating the inner race counterclockwise, and it will fall right into place. Next, we can put in the planetary assembly. Now, before we assemble the direct clutch drum, I want to show you another problem that can occur if we're not aware of the proper assembly. This bottom plate, if you can see that there is an inside step to this bottom plate. This inside step faces down on the sliding hub so that when it is installed, it's flush across the bottom. The sliding hub has teeth that protrude off the end, and this inside step fits over it like a skirt, so now the plate is completely flush across the bottom of the sliding hub. Once we have determined what type of direct clutch drum we have, we can then start placing the proper amount of frictions and steels onto the sliding hub. And we can put the top pressure plate on, and notice that the top pressure plate has an outside step, and this needs to face up. We can then place the 800-pound spring into the sliding hub, the sun gear shaft and thrust plate, secure some trans gel to the thrust plate to retain the bearing, and then we can lay this right into the housing. Now, before we can put this assembly into the press, we have to stick into the planetary the alignment tool. This will keep all the internal components in center line after we compress the 800-pound spring, so assembling the overdrive unit onto the transmission will be easier. Now, if you don't have this tool, you could use the intermediate shaft that's in the transmission, but obviously you would have to build the overdrive section first in order to use the intermediate shaft as your alignment tool. Now that the overdrive assembly is in the press, we can compress the 800-pound spring. You will have to move the direct clutches around to align up the steel tabs with the slots in the drum, and they will drop down into place. Once the spring is fully compressed, we can then put in the round retaining snap ring, and now we can put in the wavy snap ring that retains the overdrive direct clutches in the drum. We can now release the 800-pound spring. Care needs to be taken when placing the overdrive unit into the extension housing so as not to damage the governor rings. Once the unit is down, you would take your snap ring pliers and spread the retaining snap ring, and now the unit has dropped below the retaining snap ring, so to ensure that this snap ring is in the groove, you would push up from the bottom on the unit itself until you hear the snap ring pop into place. Now we can put the gasket and cover plate on the extension housing.
In this segment, we will cover the measurement check for the overdrive piston shim and intermediate shaft spacer. Special assembly tools will be shown and used. The assembly procedure follows those as shown in the ATSG TechTrans service manual.
The next step that we have to take is a very crucial step. It is making a measurement from the extension housing surface down to the sliding hub bearing seat. And when we make this measurement, you want to make sure that this bearing is not sitting on its seat. These measurements need to be taken without the bearing. Now, this overdrive piston shim is extremely crucial because as the overdrive piston comes out during the 3/4 shift, this shim pushes on the sliding hub and releases the overdrive direct clutches by compressing this 800-pound spring. So the timing of these clutches being released and the overdrive clutches being applied is crucial. If this washer or piston shim is too thick, you will lose reverse. If it is too thin, you will have a bind-up on a 3/4 shift. So this measurement is done by placing what is called a gauging bar across the surface of the extension housing. Now, this gauging bar is a 1/2 inch thick. This is the tool that Chrysler uses. Hayden Tool sells this bar as well. Now, this 1/2 inch thick bar is placed across the extension housing, and you would take your dial caliber and you would measure down to the sliding hub seat. So you would take this measurement and write it down. This measurement should be taken at 4 locations, 90 degrees apart. Add all measurements together and divide by 4. Using this measurement, you can select the proper thickness shim by going to an overdrive piston shim chart, either in a factory manual or in ATSG's TechTrans manual. The measurements that are in the overdrive piston shim chart have already included the 1/2 inch thick bar. So if you are not using a 1/2 inch thick bar, you will either have to add or subtract the difference depending on the thickness of your bar. This is very crucial in order for you to be able to select the proper overdrive piston shim. The next measurement that we're going to have to take is for this intermediate shaft spacer. And we make this measurement by placing this tool into the overdrive section. And by the way, these tools are available from the manufacturer as well as Hayden Tools. We would then place the gauging bar across the extension housing, and with our dial caliber, we would make a measurement from the gauging bar down to the tool. We would get our measurement, and we would go to ATSG's TechTrans manual or a factory manual to the intermediate shaft spacer chart to make the proper selective on the intermediate shaft spacer. Okay, now we're ready to install the overdrive clutches. But first we have to put in the snap rings. The first snap ring that needs to go in is the flat snap ring. And the second snap ring that needs to go in is the wavy cushion snap ring. Now we can put in the overdrive clutch pack, but there's something I want to tell you. There are 4 different overdrive clutch pack stack-ups. Right here you can see that we have 3 frictions. There is a 2 friction stack, a 3 friction stack, a 4, and a 5 friction stack. If you have a 2 friction stack, both pressure plates will be thick, like this one. If we have a 3 friction pack, the first one to go down will be a thin plate, then your 3 frictions as we have here, and a thick plate. If you have a 4 friction pack, you will have 2 thin plates. Now, if you have a 5 friction pack, you will have a thin plate that will go down first, and the last plate will be a steel plate. The last plate will be the apply plate. Now, because we have a 3 friction pack, we have a thin plate which goes down first. Then we would put our frictions and steels in. And then the thick plate on top. And then we would install the round retaining snap ring. And then we can secure with trans gel the bearing that sits on the sliding hub. And now we can install the overdrive piston into the back of the case, into the overdrive piston retainer. Now notice there are 2 alignment pins and holes in the back of the retainer, the pins in the back of the piston. And we can just slide the piston on, and we can put the piston in place. And once the piston's in, we can then take the overdrive piston shim and secure the piston shim onto the piston. Now, over here again to the overdrive clutches. Sometimes these overdrive clutches are known to rattle during while you're in first gear, second gear, and third gear. And when we shift into fourth and the overdrive clutches are compressed, the rattle goes away. So Chrysler came out with modified frictions to prevent a rattle in first, second, and third. And the part number for these frictions, if you have this problem, is 4461181. Now, you will only get 1 friction per part number. So if you have 2, you'll have to order that part number twice, 3 times, and so on. We are now ready to install the overdrive section onto the transmission. As you install the overdrive section onto the transmission, be sure not to damage the governor tubes. Now that the transmission has been assembled, we do have the valve body and solenoids to take a look at. And here I have the solenoids from a 500. This one here is the lockup solenoid, and this one here is the 3/4 shift solenoid. These are both normally open solenoids, which means when they are not energized, oil will enter here and here and will exhaust out the side of the solenoids. So you can check to see if physically these solenoids are correct or working properly by blowing air into the entrance hole and making sure that the passageway to the exhaust hole is clear. Now, inside the connector, as I said before, we have 3 pins on an A500. The middle pin is going to be the power supply to both solenoids. The red wire comes in and splits off and feeds power to both solenoids. Now the front pin is the ground pin for the 3/4 solenoid or overdrive solenoid, and the rear pin is the ground circuit for the lockup solenoid. So if you wanted to check this on the bench, you could supply your own 12 volts to the middle pin, and when you ground the front pin, the 3/4 shift solenoid should close and you should be able to hold pressure and nothing should come out of the exhaust port. Same with the converter clutch solenoid. When you ground the rear pin, this solenoid should close. No air should pass through out the exhaust port. Now these solenoids measure approximately 25 to 35 ohms in resistance at room temperature. So you would put your positive lead to the middle pin, and you would put your negative lead to the outside pin, and we can see here that we have 31.7 ohms. On the other solenoid, we also have 31 point, well, here we have 31.3 ohms. They're both almost identical. Now, if the ohms range is between 25 to 35, and one solenoid measures 25 ohms and another measures 35 ohms, even though they're within specifications, the two are so far away from each other that the solenoids would not be trusted. So you would have to replace the solenoids. The resistance value should be almost the same at room temperature with these two solenoids. Now, with the valve body, there's only one thing I want to bring to your attention, and that is the 3/4 timing valve. This valve is often depicted in manuals as being installed into the valve body, where the valve goes in first and then the spring. But the proper installation is the spring first into the bore here, and the valve with the stem going into the spring, and the last land goes towards the cover plate. That is the correct assembly of your 3/4 timing valve. Since the parking rod is so long, it could make installation of the valve body difficult. So you could remove the E-clip that mounts the parking rod to the valve body and slide the parking rod down into the extension housing till you get to the parking pawl. Take a pair of pliers and rotate the output shaft until the parking rod pops into place. Now, with the parking rod installed, you would carefully take your valve body, lubricate your solenoid assembly, and carefully lay the valve body into place. Then you can reach down, pick up your parking rod, and with a pair of needle nose pliers, you can carefully slip the E-clip into place, and now your valve body is easily installed. Now that the valve body is installed, you can make an adjustment to the low reverse band by breaking the locking nut loose and tightening the adjusting strut down to 72 inch-pounds and backing the strut off 4 complete turns and then locking the nut. Then the filter is ready to be installed, and you want to be sure that your solenoid wires are routed correctly so as not to pinch these wires during the installation of the filter. Now we're ready to install the pan. Now that our pan is on, we are now ready to install the neutral safety switch. And we can make an adjustment to the intermediate band by breaking the locking nut loose and again turning in the adjusting strut down to 72 inch-pounds, only you would back this strut off 2 to 2.5 turns, and then you would lock the nut. Now you have an A500 that's ready to be installed into the vehicle.
As we can see, there are differences in these overdrive units, and like any other units, there are updates and part changes. We at ATSG will keep you updated.